So type 2 questions. In this, what will be different would be that the Kc value would be given. So your Kc value is already given, and you have to figure out the equilibrium concentration. So it's the reverse now. So Kc value is given, and you're supposed to find the equilibrium concentration. Now, what you're going to do over here is, for example, you have got a reaction over here, and they tell you that they give you the initial moles. Let's say they tell you that initially. So here's a question. Here's a question. Initially, let's say 0.2 moles of H2 and I2 are mixed. Okay, so these are the other types of questions, are mixed together with, let's say, 0.4 moles of. So with 0.4 moles of one second, we had people. So with 0.4 moles of moles of HI. So that's the question. That's the initial concentration or moles of the substances. And then he says that the Kc value is 2.2. And he's asking find the equilibrium concentration. So now it's the reverse. So you're going to do everything exactly the same, but you will be solving the question in the backward direction. Find the equilibrium concentration. So first thing, what did we do previously? The previous questions were when you did the old questions, what was given was they would give you your initial moles. Okay, let me open one of the questions so we can practice. Just one second. Let's do one of the previous questions first. Where's equilibrium? Can you see Kc over here? This one. So let's try and do let me try and do a few difficult questions for Kc. We were still doing Kc questions. We'll come to this question later, the other type of question. We'll try and do some theory questions very, very quickly. So what is meant by the term dynamic equilibrium? That's simply when the rate of forward reaction equals the rate of backward reaction. That's in a reversible reaction. Write the expression for Kc for this reaction. So it's products over reactants. So it's going to be Kc is this is an ester, CH3, CO2, C2H5, concentration, water concentration divided by the reactant concentration, which is carboxylic acid, CH3COH. And the other one is ethanol, which is C2H5, OH, and its concentration. So that's Kc. Now over here, what they've done is they've so sometimes they'll give you the initial, they'll make a partial table, but they would link it up with moles. So for example, if you're given 6 grams of ethanoic acid, that there's a mixture of 6 grams of ethanoic acid. So it's pretty much the same question, except that you would have to find moles first. How do you find moles? Moles is mass divided by MR. So 6 divided by ethanoic acid, CH3COOH. That I think is 60. CH3 is 15. COO32 plus 12 plus 1, that is going to give you 60. So it's going to be 6 divided by 60. So the initial moles would come out to be, what is 6 divided by 60? It's 0.1 moles, right? So it's 0.1 moles. So he mixes 0.1 moles of ethanoic acid with 6 grams of ethanol. again convert that into moles. So that is going to be 6 divided by ethanol is C2H5OH. That is 12 into 2 plus 5H plus OH. That would give you, I think, 46. Can somebody quickly tell me how many moles of ethanol do we have? What do we get for this? Anyone's Hania, Sidra? So 6, that's 0.13. So let's take that as 0.13 moles. So we're getting 0.13 moles. And he added 4.14 grams of ethyl ethanoate, which is the ester over here. So 4.4 grams. So moles would be mass divided by MR. This thing, I think, is 88. CH3, CO2, C2H5. That's probably, you can double check that. I think it's probably 88. So how many moles is that? 4.4 divided by 88. What do we get? So we're going to get 0.05 moles for that. So this is 0.05 moles. Now, this is what we are familiar with. You have the initial moles, you have the equilibrium moles. So you started off with 0.1 moles. And now you have 0.04 moles. So that means if you compare the two, that means 0.06 moles reacted. They reacted because 0.06 moles are missing. 0.01, initially you added 0.1, now you're left with 0.04. So that means 0.06 moles have taken part in the reaction and they've gone in the forward direction. So 0.06 react and it's 1:1. So for ethanol, it's going to be the same as well. It's going to be 0.06 of ethanol that would react as well because it's 1:1. And the products would be produced in exactly the same ratio. So 0.06. So 0.06 of this ester would be produced. And 0.06 moles of water would also be, it's also going to get produced. So what are your equilibrium moles now? So out of 0.13, 0.06 have reacted. So that means 0.06 are gone. So you'll be left with 0.07 moles. Is this clear that you had 0.13 moles, but you figured out that 0.06 are taking part in the reaction? They're gone. So subtract 0.06 from that. So you're left with 0.07. Initially, you had 0.05 moles of the ester, but now 0.06 moles extra ester molecules are produced. So you have 0.11 moles, I think, for this. And initially, you didn't have any water molecules, and now 0.06 moles are getting produced. So you're left with 0.06 moles. So those. So the whole question was that you had the initial amount of substance was given in grams, and you figured out the moles. You figured out that these are the initial moles that were added into the container. The moles of one of the substance at equilibrium was given, that was 0.04. That means 0.06 went missing. That means 0.06 reacted, and we figured out that it's not going to react alone. It's 1:1. So 0.06 of this would also react. And on the other side, 0.06 of this would be produced, 0.06 of this would be produced. तो इधर मोल्स ज्यादा हो जाएंगे, ठीक है, और यहाँ पे 0.06 मोल्स कम हो जाएंगे. 0.13 subtract 0.06 because they're gone. वहाँ पे 0.06 moles extra are getting produced. So 0.05, now you have 0.11. You had 0 initially, now you have 0.06. Is this clear? Yes or no? Is this clear?
Yes, sir. सर ये कल जो आपने रिकॉर्डिंग भेजी थी इसकी इक्विलिब्रियम की, उसमें कैसी जिस जगह आपने एक्सप्लेन किया था वो रिकॉर्डिंग में वो नहीं थे, शायद तो नहीं कट हो गए थे, तो वो मुझे वो समझ नहीं आई।
केसी वाला
जी सर।
मैं भेज देता हूँ। केसी मैं इधर बता देता हूँ। केसी क्या होता है? इट्स द कंसंट्रेशन ऑफ द प्रोडक्ट जब इक्विलिब्रियम पे होती है ना कोई चीज, व्हेन समथिंग इज एट इक्विलिब्रियम, राइट? तो व्हाट हैपेंस इज that the amount of products and the amount of reactants, they become constant because the amount jitni produce ho rahi hai and the amount that is getting consumed, that is exactly the same. Like every second, if 10 molecules are produced and 10 molecules are converted back, the amount of product remains constant. Is that clear?
जी सर।
So Kc is the ratio of the concentration of the products divided by the reactants. Okay, there's going to be an equilibrium. Sometimes the equilibrium favors the products. There would be a lot of products and there would be a very few reactants. There's going to be a ratio that's going to exist. There's going to be a certain amount of products and a certain amount of reactants. So it's the ratio of the products to reactants. And this is how you write the expression. Okay, you add up, you don't add up, you multiply the product concentrations and you divide it by the reactant concentration. Is this clear?
Yes sir.
So in this case, what is happening is they always give you the initial moles. ये समझ आया था ये वाला part?
जी सर, ये वाला आ गया।
ठीक है, so you have to figure out in every KC question you have to figure out the equilibrium concentration, and then you plug in those values to find the equilibrium constant KC. That's the next part. So KC would be, in this case, product concentration. So this is your product, 0.11 into 0.06 divided by the reactant concentration, which is 0.04 and 0.07. Now this is not really concentration because I'm putting in moles over here. Concentration is moles divided by volume, but you don't need to divide by volume in this case because the volume part would get cancelled out. You can remember concentration is moles divided by volume. So all these moles are in the same container, so they have the same volume. So there's no point dividing by volume because the volume part would get cancelled out. So you can directly use moles. So you'll get the value of Kc, which is going to be what? What are you getting? What are you getting for this? Kitna hai? Did anyone calculate for this one?
Recording in progress.
Anyone? Did anyone try? Okay, so we got. So we're getting 2.36. So that is our equilibrium constant for this reaction. That's 2.36. And you have to calculate for this and explain why Kc has no units. It has no units because the units get cancelled out. Concentration into concentration, mole per dm cube into mole per dm cube divided by mole per dm cube into mole per dm cube. So all the mole per dm cubes would get cancelled out, which is why in this specific case, Kc is not going to have any units. So I'm going to do another question. This one is a slightly more difficult question. Let's do a simple one first. Just a second. If we can find one. This is the reverse. So let's do the difficult one. It's not a difficult one. It's only the thing is that it's the same question, but they've mixed it up with moles. So again, you have an alcohol reacting with a carboxylic acid forming an ester, and a water molecule is asking for the expression. So it's product concentration, which in this case is CH3CO2R. So product, these are your two products into water concentration. And you're going to divide that by the reactant, which is going to be an alcohol concentration. That's what your Kc is, and it's not going to have any units, no units. So there are no units because they get cancelled out. So that's your expression. Now, in this question, the moles part is kind of tricky. It says that in an experiment determined Kc, a student placed together in a conical flask 0.1 moles of ethanoic acid and 0.1 moles of an alcohol and 0.005 moles of HCl catalyst. So this is what's happening initially. that 0.1 moles of alcohol were added initially, and he added 0. So that's 0.1 moles of alcohol and 0.1 moles of ethanoic acid. So those are your initial moles. So that's the initial situation. And he also added a catalyst to it, which is 0.0005 moles. Now the catalyst has nothing to do with the equilibrium. And remember, a catalyst remains unchanged. So the catalyst is not doing anything in the reaction, it's just speeding up the reaction. Catalyst does not affect the equilibrium position. It just speeds up the reaction and it remains unchanged in the reaction. So even at the end, it's going to be 0.0005 moles. So the flask was sealed. So he mixes. So initially there is no ester, there is no water. Now he takes this container, he seals it up and keeps it for several days at 25 degrees centigrade. After this time, the student titrated all of the contents of the flask with 2 mole per dm cube NaOH. Now what he's doing is, whatever is present in the mixture, there would be some ester formed, there would be some water molecules formed, the amount of alcohol might decrease, the amount of carboxylic acid might get used up, and there would be some HCl. Now what he's doing is, he's titrating it with NaOH. He's reacting this entire thing with NaOH. So he's doing a titration. And the concentration of the NaOH that he's using is 2 mole per dm cube. So that is also provided. And the amount of NaOH that goes into this titration is 22.5 cm cube. So the volume is given. The volume of NaOH that reacts with this mixture is 22.5 cm cube. Now listen to this very carefully. The first part is, what is this NaOH reacting with? Now here's your mixture. You made this equilibrium. You added 0.1 mole of this, 0.1 mole of this with the HCl catalyst. There would be some ester. Now remember, at equilibrium after several days, the quantities would be different. So the quantities are not going to be the same once equilibrium is reached. लेकिन मुझे बताओ कि what would this NaOH react with? I mean, out of all of these substances, what will this NaOH react with? Can anyone guess what it would react with? I mean, it's not going to react with the water molecules. What would it react with? NaOH is a base.
Yeah, so it would react with acid, I guess. So like,
Okay, so it's going to react with the HCl. And it's also going to react with the carboxylic acid. I mean, it's going to react with acids, right? Bases react with acids. So the amount of NaOH that you're adding, it's going to react with two of the things. It's going to react with HCl and it's going to react with the carboxylic acid. It's not going to react with the alcohol. It's not going to react with the ester, and it's not going to react with the water molecules. Bases react with acids. So the first thing is calculate the amount in moles of NaOH used. So find the moles. How many moles do you have? Concentration times volume. So it's going to be 22.5 divided by 1,000, or into 2 mole per dm cube. And that gives me 0.045 moles. So he's adding 0.045 moles of NaOH. And these moles are going to react with HCl or with the ethanoic acid that is present. So the next question is, what amount in moles of NaOH reacted with HCl? Now, if you remember the equation of NaOH with HCl, NaOH and HCl react in 1:1. Like if you, let me rub this off, let me do the working here. So NaCl,
sir.
हाँ जी.
Sir, जो first वाला जो part है ना, calculate the amount of moles used in the titration. तो इसमें हमें वो पहले से given है ना 2 moles, तो हम उससे मतलब indicate करेंगे उसके लिए कोई और steps होंगे.
It's the same. He's already told us that 2 mole per dm cube of NaOH was used, and the volume that was required was 22.5 cm cube. the volume and concentration is already given that during the titration, when he mixes the NaOH and reacts it with the whole mixture, this is the amount that is used. So you can find moles, concentration times volume. Clear?
Yes, sir.
So now the question is, he's asking, okay, what amount of NaOH reacted with the HCl? So NaOH and HCl react in 1:1. Now, how many moles of HCl were present in the container? It was 0.005 moles that were added. Now, according to the ratio 1:1, the amount of NaOH that would react with it would be 0.005 moles as well. So we know now okay, the amount which was 0.045 moles that was added. HCl was a catalyst. It did not, catalyst, remember, don't undergo any change in the reaction. Their amount remains the same. Okay, at the beginning, it's 0.005 moles. So after several days, it's still going to be 0.005 moles because it's a catalyst. So the HCl that's present in the mixture is 0.005 moles. So according to the ratio, 0.005 moles of NaOH is going to react with HCl. Dala kitna, you added 0.045 moles. So the question is, what is the rest of the NaOH doing? The rest of the NaOH is how much? 0.04 moles. Okay, that's the question. That the total amount of NaOH that's reacting. Let me just. So the total amount of NaOH that is reacting is 0.045 moles, and we figured out that 0.005 moles is reacting with HCl. So what is the rest of the 0.045 moles, which is